Hello and welcome to today's class. Still yet on the second method of differentiation called the first principle method. Last class we have dealt with several examples under first principle, right? Still yet, let's do more example under first principle to further increase the in-depth understanding on how to evaluate problems using first principle. Usually, let's say I have example 3. Let's say I have that y is equal to s cubed. Let me call it example 3. Let's say I have that y is equal to s cubed. To differentiate this using first principle, what do? But I always say that before you use first principle, try checking out your first method called the general method, right? Which says that multiply by the power and subtract 1 from the power. That's like the concept for general method of differentiation. So let's say I'm given that y is equal to s cubed. If I'm to apply general method here, the change in y with respect to x here becomes the y over the x as being equal to, you said, multiply by the power. The power here is 3 times, repeat the question, x to power 3, next up, minus 1 from the power. Multiply by the power and subtract 2 from the power. That's all. From here, the y over the x here will be equal to 3x. 3 minus 1 is of course 2. So if I differentiate s cubed, I will have 3s squared. Similarly, let's apply first principle and let's see if our answer will be comparable. For this first task here, we said for first principle, to this y, hard change in y, right, is equal to this x here, hard change in x. Then the cube comes around this place, right? What's the next task after taking your first concept to y change in y to x change in x? What's the next task to do? Of course, the next procedure here is quite easy, as taking y to the other side, so it becomes change in y is equal to x plus change in x all cubed. Take this y, becomes a minus y. At this point here, I'll simply take this y to the other side, becomes what? A negative y. From here, what's the next task here? I'll now say but y was equal to what? The s cubed from the question. Y was s cubed from the question. So it's easy that I'll have that change in y is equal to x plus change in x all cubed, this minus y. But y is what? S cubed. So I have s cubed here. So at this point now, I'll try to expand s plus change in s cubed. Last class, I tried to expand x plus change in x squared, right? And I had an expression. Let's simplify this one here. If I'm to simplify this, it becomes change in y is equal to s cubed plus 3x change in x plus 3 squared change plus 3x change plus 3x squared change in x plus 3s change in x squared plus change in s cubed. If I have to expand x plus change in x cubed, I shall have s cubed plus 3x change in x squared, 3x squared change in x plus 3x change in x squared plus change in s cubed. Okay, let me see if I'm correct actually. So if I expand this one, I shall have everything here. But mind you, I'm still having a minus s cubed. So I'll keep that guy pending. Let me show you how I got to this expression. This term means x plus change in x is multiplying x plus change in x, still multiplying x plus change in x in 3 places. S cubed. The cube means 3, right? Last class, when we did just these 2 alone, we add x squared plus 2x change in x plus change in x squared. These two alone last class gave us this expression. So I'll drop this man here, I'll drop it down. X plus change in x. What's the next task? Of course, I'll pick out this first x here, pick out first x, I'll pick out x into, pick out this first x into everything here. That's x squared plus 2x change in x plus change in x squared. Pick out this first term x into everything here. What's the next term here? Plus change in x. Pick out plus change in x into everything that becomes x squared plus 2x change in x plus change in x squared. So I have this. Next task from here is to expand through x times x squared. That's x cubed plus x times 2x in x. Here becomes 2x squared change in x, right? X times x is x squared. These two comes down and this is comes down. Plus this multiplied by this is as x change in x squared, right? Plus this multiplied by this, that becomes x squared change in x plus this multiplied by this, I shall have 2x change in x squared. Finally, this multiplied by this is a square here. So change in x times change in x squared, that's what? Plus change in x cubed. So I have this. At this point now, I can see like terms, right? What are the like terms here? Of course, x cubed remains the same, x cubed. See x squared change in x. I can see x squared in x here. The number in front of here is 1. So 1 plus this 2 here should give 3. That becomes plus 3x squared change in x. I've picked this, I've picked this, and I've picked this. Remaining this, this, and this. So this is x in x squared, also x in x squared. The number here is 2. Number here what? Invisible 1. 1 plus that 2 is plus 3. That becomes 3x change in x squared. Plus what there? The last one, I've picked this and this. What left there? This only left value variable. That becomes change in x cubed. So if I expand these three, I'm expected to have this answer as being the value there. So observe, I have x cubed plus 3x squared in x, 3x squared in x plus 3x in x squared, 3x in x squared plus in x cubed, right? So I have this one here, minus x cubed. You might be wondering, how do I know how to expand this without solving? You might be wondering that you want to know that faster. It's quite easy task. Just check this kind of video. I'll drop the link there on how to solve this easily, how to master the shortcut, right? So try to do well to watch my video on binomial theorem, right? Using the concept of Pascal's triangle. Is from there you learn how to use this stuff shortly. So I didn't used to, I just for teaching's sake. That's why I expanded, right? If I'm not to expand, if I'm in an exam, I need to start expanding this way. I should apply shortcuts. So if you're interested in the shortcuts, just take a tutorial video of mine under binomial theorem using Pascal's triangle to learn how this works. From here, I'll observe that x cubed will cancel out minus x cubed. So plus x cubed cancel out what? Minus x cubed. What do I have left? I'll have that change in y is equal to 3x squared change in x plus 3x change in x squared plus what? Change in x cubed, right? These are the left expression there. So let's proceed from here. All right, from here, what do we get from here? I'll have my change in y. All right, basically, if you're familiar with what we have done last class, right? before you can watch this video, do well to watch our previous classes on first principle, so that you'll be familiar with what I'm doing here. So observe that in our previous examples, if I cancel out any parameters there or any variable, I'll end up having what I'm having left here. And also at this level, my next task is what? Divide through by x. So at this point here, I'll divide through by change in x. So I'll have change in y over that change in x is equal to, said pick the term individually and divide them by change in x. That's the concept. From here, I'll have 3x squared change in x over change in x. That's for the first one, plus second one there is what? 3x change in x squared over change in x. The last one there is plus change in x squared over change in x. So I have, x cubed, change in x cubed over change in x. So I have this. Obviously, it's clear that for mathematical approach, this will cancel this, but we left is what? One of it here. This will cancel this. I'll left with 2 of change in x squared here, right? So I have this squared here. So what am I having left? So I'll have that change in y over change in x is equal to, I'm having 3x squared here, 3x squared left, plus having 3x, next up change in x, also plus change in x squared. So I have this. At this junction here, we said whenever you divide through by change in x and you are still left with what? Change in x, you take the limit of change in x to be 0. So taking the limit of change in x to be 0, in a layman approach, it means that anywhere I see change in x, I'll put 0. From here, this becomes change in y over change in x is equal to 3x squared plus 3x into, this is change in x, becomes what? 0 plus what? 0 squared. If I do mathematics here, I'm expecting that my answer becomes change in y over change in x is equal to what? 3x squared. This becomes my answer. Of course, 3x times 0 is 0. 0 squared is 0. So these two 0 are nothing. They are half. Left it was just only what? 3x squared. So of course, observe when I expanded this term using general method, I had 3x squared. Also, when I use first principle, I still have yet 3x squared. This is how to solve problem using the first principle method of differentiation. If you like this video or if you find it helpful, do it to like, hit the sub button, subscribe to this channel, and also share to your friends and classmates that are finding it difficult so that they can learn too. See you in the next class.